In this next example, we're going to look at how to find instantaneous rate of change without graphs and without limits. So in example 9, a farmer has 200 trees yielding about 15 bushels of oranges per tree. So something like that, where each tree has 15 oranges per tree. He is expanding the farm by 15 trees every year, while each tree improves its annual yield by 1.2 bushels per tree. So let's go back and break down what we just read. So he starts with 200 trees, and each tree has 15 bushels of oranges. So this and this number represents an initial amount. And then every year, he expands by 15 trees, and each tree improves by 1.2 bushels per tree. And what we want to know is what is the current rate of change, or rate of increase, of his total annual productions of oranges. So he's doing two things. The first thing is he's increasing how many trees he has each year, and each tree is increasing how many bushels it has per year. And so something to keep in mind is that the rate of increase is the derivative. So what we're going to do is we're going to find out an equation that's going to tell me how many oranges are produced at any given time. So the first thing we need to do is give an equation for each part of our problem. I'm going to let t of x represent the number of trees in x years from now. And I'm going to let y of x represent the yield per tree x years from now. So it's how many bushels of oranges are on the trees. Well, if we have this, then we have p of x is equal to t of x times y of x, and this represents the total productions of oranges x years from now. That's because production is the number of trees times the yield per tree. And so let's talk about the information that we already know from this problem. Well, we know that t of 0, which represents the number of trees at year 0, which is right now, and we know that number is equal to 200. We also know that t prime of 0 represents the numbers of trees expanding, which is our current rate of change of trees. We also know that y of 0, which represents the number of bushels in each tree right now, which represents 15. So the number of bushels that we have in each tree is 15. And we know that y prime of 0 is equal to the rate of change of bushels, which represents 1.2, because they're increasing by 1.2 bushels per year. So this is all the information that we know that the problem has given us. Since production is given by p of x is equal to t of x times y of x, the rate of increase is given by the derivative. So what we want to find now is the derivative of p. So we have p of x is equal to t of x times y of x. And so when we take the derivative, we're going to be using the product rule. So p prime of x is equal to the derivative of the first times the second, plus the first function times the derivative of the second. Now what we want is the production increase right now. So I want the current rate of production per year. So I get that p prime of 0, because this is the rate of production right now, is equal to t prime of 0 times y of 0 plus t of 0 times y prime of 0. And so now we're going to use all that information from earlier. So we get that t prime of 0 is 15 times y of 0, which is also 15, plus t of 0, which is 200, times y prime of 0, which is 1.2. And then we multiply those out, and you end up getting 465 oranges per year. So this is the change in production of how many oranges I am going to add to my crop per year. So one thing to remember is that the derivative is the slope or the rate of change at any point given on a curve. If you are given a graph of x and asked to find the graph of the rate of change, you just have to find the derivative graph. So that's something that will come in handy as we start graphing derivatives.